Hi, I'm Cheryl Leach. In this problem, we're asked to find the exact values of the 6 trig function values for our given angle theta. Well, one way to look at trig function values is that they are the variety of different ratios that you can create by looking at the x and y coordinates of a point that's on the terminal side of your angle and the length of this line segment, the one that goes from the origin to that point that's on the terminal side. Well, I already know the x coordinate and the y coordinate, but I need to figure out what that length is. Well, how can I do that? Well, let's go ahead and take a look at a triangle that can be created using that point and the origin. Notice that that's going to be a right triangle. This length is going to correspond to the x-coordinate of my point. This length will correspond to the y-coordinate. So that takes care of the legs of the right triangle. But how about the hypotenuse? I can use the Pythagorean Theorem to figure out that length. So I'm going to have -12 squared plus -5 squared equals, and I'm going to call that length r. So it's going to equal r squared. This is going to be 144 plus 25 equals r squared. And so 169 is going to equal r squared. That leaves me with r squared, or excuse me, r being equal to plus or minus 13. And in this application, we're only going to be using the positive version. So r, which is the length of this line segment, is going to be the square root of 169, or 13. Okay, so now what I have are 3 numbers. My x-coordinate of -12, my y-coordinate of -5, and my r value of 13. And I need to look at all the different ratios that I can create with those 3 numbers. So let's go ahead and take a look at the sine function first of all. The sine of my angle theta, by definition, is the y-coordinate divided by that r value. And in this case, the y-coordinate is going to be -5, and the r value is 13. So the sine of my angle is -5 over 13. Let's go ahead and set up those ratios for the other 5 trig function values. The cosine of theta is going to be the x-coordinate divided by r. The tangent is going to be y divided by x. The cosecant of theta is going to be r divided by y. The secant of theta is r divided by x. And the cotangent is going to be x divided by y. Notice when I have those 3 elements, I'm looking at all the possible ratios, and they're each given a special name. All right, so I've already done it for the sine, but let's fill in the other 5 trig function values. For the cosine, I want x divided by r, which in this case will be a -12 divided by 13. The tangent is the y-coordinate over the x-coordinate, so that will be -5 divided by -12, which can be reduced to 5 over 12. The cosecant is r over y, so that gives me 13 divided by the y-coordinate, which is -5. Secant is r, which is 13, divided by the x-coordinate, which is going to be -12. And finally, cotangent is x divided by y. The x-coordinate is -12, the y-coordinate -5, and this one can be reduced to 12/5. Notice that the sine and the cosecant are reciprocals of each other, as are cosine and secant, and tangent and cotangent. I hope this is helpful. Thanks.